Tension members design strength due to block shear failure. The various failure modes are shown in which this block gets separated, and along the load direction the plane is called shear plane, and whereas perpendicular to the load direction this plane is called as tension plane. In this case, if load is applied in this direction, the parallel planes are shear planes and perpendicular plane is tension plane, and this part of the block gets separated. In case of weld also, along the load direction are called shear planes, and perpendicular to the load tension plane exists. The terms ATG and ATN, that is net and gross and net area of tension planes, whereas AVG and AVN are gross and net areas of shear planes. Shear is represented by V and tension by T, whereas in case of welded sections, since bolt holes are not present, so the net area of tension plane and gross area of tension plane will be same, whereas net area of shear plane and net gross area of shear plane will be same. So design strength due to block shear failure, that is TDB, is given as least of TDB1 and TDB2, where TDB1 is given as 0.9 times of net area of tension plane into Fu by gamma m1 plus gross area of shear planes into Fi by gamma m0 into a root 3. Whenever shear is encountered, a root 3 is divided. This is tension, rupture and shear yielding. Tension is in rupture, so net area is considered and Fu is considered. Whenever net area is considered, the factor 0.9 should be present, whereas shear is in yielding, so gross area is considered for shear and Fi is considered in case of yielding, and whenever shear is encountered, a root 3 should be divided, whereas the other one is tension yielding and shear rupture. In which the TDB2 is given as, since tension is in yielding, gross area should be considered for tension and Fi also should be considered by gamma m0, and shear is in rupture, so net area with a factor 0.9, so shear is net area is considered for shear into ruptures, then ultimate should be taken, so Fu by gamma m1, and whenever shear is encountered, a root 3 should be divided. The reason for root 3 division is, in case of distortion energy theory, or also called as shear strain energy theory or von Mises theory, which is given as sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 should be less than or equal to Fi square. In case of pure shear, in pure shear case, that is tau all around, sigma 1 and sigma 2 are tau only, Sigma 1 is tau, whereas sigma 2 is minus tau. If we draw the Mohr circle for pure shear case, this will be the Mohr circle, in which this is the tau plane and this is sigma plane. So 1 tau is positive, 1 is negative. Then major and minor principal stress is also, one will be positive and the other one will be negative. So one is positive and the other is negative. Substituting, tau square plus 1 is negative, so minus of tau square minus tau into minus tau should be less than or equal to Fy square. So this becomes 3 tau square should be less than or equal to Fy square. Then tau should be less than or equal to Fy by root 3. So whenever shear is encountered, Fy should be divided by root 3. So only root 3 is encountered. So least of TDP1 and TDP2 will be the design strength due to block shear.